The following video will go through population ecology. Populations consist of individuals of the same species that live in a given area. So for example, all the pike in a lake will form a population, or all the students within White Oaks form a population. Now population density can be calculated based on this, and population density refers to the number of individual organisms in a given area. Or we can put that as a mathematical formula where D is equal to N over A, so number of individuals divided by the area. So in the following example, there are 223 geese living in a 50 meter squared area. What is the population density? So using our formula of density is equal to the number of individuals divided by the area. You can simply take the fact that we have 223 geese and divide it by 50 meters squared, and this gives us 4.46 geese per meter squared. So every square meter we have about 4.5 geese. Now obviously you can't have half a goose, so it'll range from somewhere between 3 to 5 what you actually count. But when you average it out, it's about 4.5 geese per meter squared. Now population sizes can change due to different factors. So they can change due to natality, which are births, mortality, which are deaths. So populations will increase if there are births. They will decrease if there are deaths. If populations will increase if there is immigration, and this is movement of individuals into a population, or populations can decrease with emigration. This is movement of individuals out of a population. Now, populations can also be open, which is natural, and they're affected by all four factors. Populations can be closed or artificial, that are affected by natality and mortality only. So, for example, a population of penguins in a zoo would be an artificial population, whereas a population of penguins found in the Antarctic would be a natural population, to be affected by all four of these factors. Now there's other factors that affect population density. So there's density-dependent factors. These are those that have an increased or decreased effect depending on the number of organisms present in a specific area. So for example, predation, disease, availability of food can be density-dependent factors. Density-independent factors are those that affect the population regardless of population density. So natural disasters, human intervention, climate. So, a flood will happen, can happen regardless of the density of a certain population, whereas something like a disease may need a certain density of organisms in order to spread or be available. So based on factors that can affect population size, you can calculate the growth rate of a population, and you can calculate the percent growth rate. So that percent growth rate is equal to the number of births in a population minus the number of deaths plus the amount of immigration that has happened minus the amount of emigration that has happened. You divide this by the initial population size, multiply it by 100%, and it will tell you if a population is increasing or decreasing. And so remember, growth rate can be a negative number, which would mean that there was a percentage decrease in the population. So in the following example problem, we have a house sparrow population that has a birth rate of 50 birds per year. 3 birds immigrate and 18 birds emigrate. There were 38 bird deaths. we're asked to calculate the percent growth rate if the initial population size is 25 birds. So in calculating that percent growth rate, we had 50 birds that were born, 38 birds that died. We had 3 birds that immigrated, moved into the area, and then we had 18 birds that emigrated, that left the area. And this all started with an initial population of 25 birds. And then, of course, we multiply that by 100 because we're wanting to put this as a percent. And then, when we do all of our addition and subtraction, we get minus 3 over 25, still times 100. And this gives us a growth rate of negative 12%. So this tells us that our population has decreased by 12% compared to that original population. And so there are also limits on a population. There is the biotic potential. This is the maximum number of offspring that a species could produce if resources were unlimited. Biotic potential is regulated by 4 important factors. So birth potential, the maximum number of offspring per birth, so how many offspring can be born at one time. So, for example, elephants will have 1 offspring every couple years, or, gestation of offspring is like 1 every couple years, and we'll typically only have 1, whereas mice will have several, anywhere between like 2 to 8 offspring per birth. The capacity for survival, so the number of offspring that reach reproductive age. The procreation, the number of times the species reproduces per year. So like a female elephant will have a calf once every like 5 years. I think the gestation period is like 24 months. It's a long time. Whereas a female mouse can have litters like 3 or 4 times a year. So that's a lot. And then the length of reproductive life, so the age of sexual maturity and the number of years the individual can reproduce, all limit all have an effect on that biotic potential. And then there are limiting factors as well, so an environmental factor that prevents an increase in the number of organisms in a population or prevents them from moving into a new habitat. And so these can be broken down into abiotic and biotic factors. So there's abiotic factors that would cause a population to increase, such as a favorable temperature, or factors that could cause a population to decrease, such as an unfavorable chemical environment. So if salt levels become too high, for example, or there's new toxins introduced into the environment, this could cause a population to decrease. Biotic factors that could cause a population to increase includes things like sufficient food, low numbers of predators, few diseases, and a high ability to compete for resources. Biotic factors that would cause a population to decrease would include insufficient food, high number of predators, strong diseases or many parasites, and an inability to successfully compete for resources. And so all of these factors all play into population size, that competition, predation, parasitism and disease, human disturbances, forest fires, and other climate extremes all affect population size of an organism. And so the purple arrows indicate biotic factors, and the green abiotic. And biotic and abiotic factors all work together and all contribute to that population size. And so that is the end of this video for population ecology.